Hello, good morning, good afternoon, good evening, Professor. We are from group 12, consists of two persons. My name is Ahmad Rizal and my friend's name is Soeputra. Uh, we are here to present our final project related to social network link prediction. Then our final project is we are going to make or create a friend recommendation system that combining classical graph feature with not two factor embeddings to predict who might be next for friend recommendation. This is our agenda for today's presentation. The first one is our motivation, why we choose the link prediction. Then our data set that we use to running our experiment, then our methodology result. In result, we compare three different models, which is linear regression, random forest, and his gradient boosting. Then our recommendation result, one example from our result, then lastly is discussion. Then the first one is why link prediction. Then every people may panel is a link prediction model in a production. From our data set, we can collect our data that there is a 1.08% of all possible user pairs are actually connected, then for 43.69 average friends per user, but the maximum is around 1000. Then around almost one ROC our best model achieved on this task. The main problem is that social networks are sparse. Most user base are not connected yet. Platform must recommend a small high quality of set of net connection out of millions candidates every day. So the question is, we consider the current friendship graph is that possible to predict solely based on its structure, which is users are currently not connected but are most likely to become friends. So this is our data set that we use, which is the Snap Stanford Facebook Eager Network. A real anonymized friendship graph consists of around 4,000 nodes and around 88,000 edge and 1% density, and then average degree is around 43, then median degree is 25, then min degree 1, and max degree is around 1000. This is our methodology pipeline, consists of several 6 steps. The first one is we try to load the graph, then split the edge, then sample negative, then we try to balance. So 1 by 1 balance pairs, then extra graph feature using not two factor embeddings. Then we train our classifier using three different model, which is a linear regression, random forest, and his graph boosting. Then lastly is our result, which is the recommended top key per user. This is the feature, the classical graph feature consists of common neighbors they use to more share friends, then Jacobi coefficient to normalize the neighbor overlap. There is a academic either to where share friends count more, then resource allocation, then preferential attachment, then last one is degree statistics. This is our not two factor embeddings configuration. Then there are three different configuration. The first one is only graph. Then the next one is fast, consists of 32 dimension. Then works is 5 times 15. Then last configuration is a full, consists of 64 dimension. Then works as 10 times 30. Then how it works, that the first one is generate biased random walks, then treat each word as a sentence, each not as a word, then try and skip gram word to factor. Then on the works, last one is each not you guess an embedding factor. This slide will be continued to my friend presentation, please.
Okay, so let's look at the model performance. After we compare the three models using the same vector set and evaluated them on the out edge, the base model is a high gradient boosting with the ROC AOC 0.99 and F1 score around 0.97. This means the model is very strong at the distinguish real friends link from the non-links. One important observation is that all models achieve more than 0.99 AOC, which show that the graph structure itself already around the contain a very strong signal. Okay, next. This slide is talk about the what drives the predictions. Based on the random forest feature important, the top four feature account for around 89% of the total importance. The interesting is the all these top feature are neighborhood overlap measure, and then between the model mainly relies on mutual friends to predict future links, and then the academic other and the resource allocation are especially useful because they don't treat all mutual friends equal. And then the last one is degree-based feature only contribute around 7%. So simply being active or having many friends is not enough to make a strong recommendation. Okay, next. And then this slide is talk about the friend recommendation in action. After training the model, we can use it to regenerate actual friend recommendation. Here we show an example for the user 107, who is the highest degree user in the group with 1045 friends. The model score candidate users who are not currently connected to user 107, then ranks them based on the predict probability of the links. For the example user, the top one is the 492, the highest recommendation score with around 0.91, followed by the second one is 559. This ranking is useful because in a real application, we don't only need to predict whether a link exists, we need to recommend the top candidate to the user. Alright, next. And then this is about the discussion and the future works. After I think our result is strong, but there is still important limitation. The first thing is the dataset is only a static snapshot, so we cannot truly test whether the model predict future offensive over time. And the second thing is the negative sample are randomly selected non-edge. This makes the task easier because the many random pairs are obviously not likely to become the friends. The third one is we only use the graph structure. We don't use other user attribute like the data allocation and other. So the future works, we can test the graph neural network, combine the structural and attribute vector like another data, and then evaluate the recommendation quality using the K precision and recall. And the next one. So this is the last one. For the conclusion, we take the three important points. The first one is the graph structure alone is already very powerful for the link prediction. In our experiment, topologically based filter achieve AUC 0.99 without other user attribute data, or we are not using the deep learning. And then the second thing is neighborhood overlap is the strongest signal. Feature like academic other and then resource allocation dominate the model because meaningful mutual friends are highly informative. And then the last one, our pipeline is modular and ready to reproduce. It starts from the raw leads, extract the graph feature, and then train the machine learning models, and finally we can produce and rank friend recommendation. I think that's it from us. Thank you for your listening.